Before we start section 12.3, if we were in class, we've learned a lot of derivative rules, and I probably at this point would give you a derivatives quiz. So I'd like you to, right now, pause the video and see if you would be able to tell me what the derivative rules are for all of these different derivatives. A, B, C, D, E, G, and H. We haven't learned F yet. We will in a second in the next section. We're going to add a few more rules to this list, and so eventually there'll be what, 2, 4, 6, 8, 9? 6, 8, 9 rules that you'll have to memorize, okay? But for right now, you should know 2, 4, 6, 7 of them. So could you pause the video and see if you can tell me what the rules are? That's the first step in all of these problems. You got to know what the rules are, or else you're not going to be able to apply those rules on the exam. So pause the video, come back to me, and make sure you have all the same derivative rules I do. All right, for the derivative of any constant, you should have 0. For the derivative of x, you should have 1. For the derivative with power rule, x to the nth power, you should have n times x to the n minus 1 power. If I have a constant in front, if it's just a number, I should be able to leave that number out in front and then just take the derivative of the rest of my function. If I have terms separated by plus or minus signs, then the rule is that I can just simply take the derivative of each piece separately as long as they're just separated by a plus or minus sign. All right, the last two are our new ones. We have product rule and quotient rule. If I have two functions being multiplied and I can't make them look any nicer, the only way that we can find the derivative is by doing that product rule. That's the first times the derivative of the second plus the second times the derivative of the first. You could have actually had those terms flip-flopped and it would be okay because of the plus sign, but on the quotient rule, it does matter what order you have it in, so be careful on that one. So the last one is the quotient rule. That's if I have two functions and they're being divided, and if we can't separate the fractions or bring up the denominator, we can't simplify it any other way, then we have to use quotient rule. Quotient rule says, in this order, the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Hopefully you know all of those rules so far, because we're going to add a few more to our list here in a second. We're going to talk now about chain rule, 12.3. All right, so suppose I asked you to differentiate this function, 2x plus 1 to the third power. Unfortunately, we can't just use our power rule and try to bring that 3 forward and subtract 1 from the exponent. The derivative of this is not 3 times 2x plus 1 squared. The only way at this point that we would be able to find the derivative of this is actually take this 2x plus 1 times another 2x plus 1 times another 2x plus 1. It's cubed, right? There's 3 of them. You would have to FOIL all of those out, combine your like terms, find the derivative, and then refactor it. I did it on a piece of paper, and I think it took me 9 steps in order to do it, making sure I didn't make any mistakes. That's a lot of work, right? Well, there's an easier way to do it. The derivative, really, is 6 times 2x plus 1 squared. See if you can find a pattern. Because what happens if I change that problem, and instead of a 3, what if this exponent was a 13? Whew! You wouldn't want to have to do 2x plus 1 times 2x plus 1 13 times, right? So there must be a way that we can find the derivative. Well, after working it out, the derivative of this one is actually 26 times 2x plus 1 to the 12th power. Do you see how we can get from the original problem to the derivative without foiling our butt off? Well, it's called the chain rule. We're going to talk about that and do some examples in the next video. What we do on the chain rule is we take our exponent, we find the derivative of our outside function. That's something to the 13th power. So that's power rule. By bringing our exponent forward, that's the 13, keeping our inside the same, subtracting 1 from my exponent, so it's a new 12. But then if you notice, I also have an extra 2 in here. That's actually the derivative of my inside. So if it was back to that 3, I would bring the 3 forward, and use my, and use my power rule. I would bring my 3 forward, I would keep my inside the same, I would subtract 1 from the exponent, just like power rule says to do, but then I would need to make sure that I multiplied by the derivative of the inside. That's how we can get the derivative of anything that has an inside function. We often use this, it's called chain rule, when we have a composition function. We have an inside and an outside function, a function inside of a function. The chain rule says, so add this to your list of rules, we're going to take the derivative of the outside. That might be power rule, that might be quotient rule, that might be product rule, but whatever your outside function is, we're going to take the derivative. We're going to keep the inside the same, but then we have to make sure that we multiply by the derivative of that inside. We've actually been doing chain rule all along. For example, if I gave you this function, x to the 5th power, if you think about this x being your inside function, we can find the derivative of this by doing the chain rule. We can bring the 5 forward, we keep the inside the same, we subtract 1 from the exponent, and then we multiply by the derivative of this inside. And what's the derivative of x? 1, right? And 1 times 5x to the 4th is really just 5x to the 4th. That's why the 1 hasn't made a difference in all of our previous problems. But we have to be careful now. If there's anything inside that's more than just an x, then we have to make sure that we use chain rule. So even if the problem changed and I had a 2x to the 5th power, this is a chain rule problem. So anytime there's more than just an x on the inside, and we have an inside function and an outside function, we have to make sure that we apply the chain rule. So that's another rule on our list. I think that's 8 now. Make sure that you practice all 8 rules and you know how to apply all of those rules. In the next video, we'll do some examples using that chain rule.